Thank you, Sarah. So we're going to talk first, set the stage in terms of our motivation for the pedagogical approach that really has drawn from a lot of different kinds of approaches in the field. And the theme we want to sort of keep in mind is coherence from the student's perspective. If we were to ask kids, why are you doing what you're doing? We really want them to be thinking in terms of questions they're trying to figure out or problems they've identified about the world that they're trying to solve, and not just that they're working on a lesson with the instructions that the teacher told them and we have no idea why we're doing what we're doing. So that's sort of the theme. Let's see if I can advance the slides. I'm not getting control. Okay, here we go. So as most folks know, the framework for K-12 science was charged with synthesizing everything we've learned from the last several decades of research about what's working and not working so well in science education in the US. And that informed the design of the next generation science standards. One big theme that came out was the need for greater coherence. We teach too many different things and not enough depth. The framework talks about long lists of detailed and disconnected facts. And so the recommendation is that what we should be doing is organizing our standards and our work with students in terms of a developmental progression, so that every time that we're engaging with some science idea, we're building on what kids already know about the world, we're eliciting their curiosity, we're building on what they figured out about how to do science in the past and what they figured out about specific science ideas. And so this means that in order to really organize learning experiences for kids, we need to start with their questions, get them interested in the phenomena that we want to study that are the rich scientific contexts. We want to build on their prior knowledge, and it's really all about making connections. We don't want the science they're learning to be separate from everything else. So we sort of summarize this in a label we call storylines, and this builds on work from the Next Generation Science Storylines Project, from the Inquiry Hub in University of Colorado, from Project-Based Science, and lots of other influences. And in order to do this in a systematic way with kids, we think about 5 questions. And today what we're going to do is take each of these in turn and talk through some strategies for working with these questions. And just to give you an advanced organizer here, we have to figure out, how do we start off? How do we kick off investigations in a unit? Then how do we work with kids to figure out where we're going next in a way that is sensitive to where we need to go for the learning goals? Then how do we do 3-dimensional learning? How do we engage kids in science and engineering practices to build the ideas? And then as we're building all these different ideas, how do we keep track of them? And how do we help kids put them together across time? And then the last piece is sometimes kids will reach a state where we sort of think we're done, but we may need to push kids to go deeper. In other words, how do we elicit dissatisfaction with the ideas, the models, the explanations that we've built so far?